All right, so we have negative exponents. Now, we have talked about what to do when we're dividing. When we divide, we subtract. So I'm going to rewrite this as multiplication. So 8 to the third over 8 to the fifth is equal to 8 times 8 times 8. And 8 to the fifth. Now you can see we clearly have more 8's in the denominator than we do in the numerator. Now when I cancel these out, it's not going to give me a 0, it's going to give me a 1. And on the bottom, I would have 8 squared, which I can also write as 64. So when we use our division rules, we're going to find that 8 to the third minus 5 is going to give us 8 to the negative 2. When we wrote it out, we got that answer, so that means these two must be the same. So we are looking for, what is that rule? So what does this tell us about numbers with a negative exponent? So if I have a negative exponent, I need to turn it into a positive exponent. And the way I'm going to do that is I'm going to take my 8 to the negative 2, and what I'm going to do is I'm going to move it to the denominator, because right now it's a numerator. So I'm going to move it to the denominator, and when I do that move, that turns that into a positive, which is how I get that answer. So some examples of that: 8 to the negative 5, remember, think of it as a numerator. And I am going to move it down to the denominator. So I have 1 over 8 to the positive 5. So the negative 5 became a positive 5. As an algebraic rule, I can say, well, that means I'm going to move it down to make my exponents positive. So let's take a look at some of these here. So I'm going to simplify, and I'm going to use the negative property to move the exponents. So on this one here, I would get 2 to the 8 minus 11. Well, 2 to the 8 minus 11 is 2 to the negative 3. Well, I'm going to have to move that down to the bottom. And then I could also think of that as 1/8. And if I were to write all those 2's out and cancel, I would find the same thing. Over here, you know, this isn't too bad. It's not as nice to write as my one up top, but this one, wow, to the 50th power would get a little obnoxious to write 50 b's out and then cancel out with the bottom. I'm going to think of these, remember, as separate. So 100 divided by 200, I can just get rid of my zeros there. So I'm going to end up with a 1/2. And then I'm going to have b to the 50 minus 75. Which is going to give me a b to the negative 25, which I could also write as b to the negative 25 over 2. Well, I can't leave it like that. I cannot leave negative exponents. So I'm going to move it down. So I have 2b to the 25th power. Now I need something up here. It's not undefined. So when I moved it, I left the 1. I'm going to continue on. I'm going to write these down here. So I have negative 3 minus 5a, b to the 7 minus 2, and c to the 5 minus 7. Now when I do these, I'm going to end up with a to the negative 8 and a c to the negative 2, but my b is staying positive. Well, that means these are all over top of 1. So that means the a needs to go down and the c needs to go down, but the b gets to stay up top because its exponent is already positive. And when I move down there, those exponents become positive, and I still make sure that I have them in alphabetical order. Now, when I go and I have the exponent outside, so a power to a power, and it's negative, that means the whole thing is going to flip. So I can take this and think of it as being over top of 1. And this is telling me I'm going to flip the whole entire thing. So I'm going to have 1 over 2x to the third y to the negative 5th. and I am squaring all of that. I am squaring all of that. And I'm going to show you another reason why that y to the negative fifth stayed the negative fifth there in just a second. Now I'm going to square everything inside and then move exponents as needed. So I get 1 squared over 2 squared, x to the 3 minus 2, and y to the negative 5 times 2. What that's going to do is that is going to give me 1 over 4, x to the 6th, y to the negative 10th. Well, this is negative. And once again, I'm going to move it, only this time it's in the denominator, so I just need to move it up to the numerator. Well, there's going to be a 1 in front of it. I don't need to write that anymore because I have something else to put there. So I've got y to the 10th over 4x to the 6th. Now, if I had taken this before I started and not flipped it, if I had passed out that negative 2 and then done all my movement from numerator to denominator at the end, I would have gotten 2 to the negative 2nd, x to the 3 times negative 2, and y to the negative 5 times negative 2. Well, 2 to the negative 2, I'm like, oh, wait a minute. Now I've got a fraction going on. So I'm going to move that down, and that is going to be x to the negative 6, so I'm going to move it down here. So this would be the negative 6 here. Now, negative 5 times negative 2 is actually going to give me a positive 10. And so it will stay up there. And then the only thing I would have left would be to do that 2 squared, so I'd have y to the 10th over 4 times x to the 6th. This one down here says classify the following as greater than 1, equal to 1, or less than 1. And so I have 2 to the negative 3rd, and I'm like, that means I really have 1 over 2 to the 3rd. Well, 1 over 2 to the 3rd is going to give me a fraction, and so that is going to be less than 1. Two to the 0 power is going to be equal to 1 because anything to the 0 power is equal to 1. Same thing here. So those are equal to 1. That negative 2 exponent right away is going to be less than 1. This one is a positive exponent, so it's going to be greater than 1. I guess I could be using our symbols, huh? And this one is also going to be greater than. Didn't need the greater than. I already did it. Greater than 1. So I could write that as 2 to the 3rd greater than 1. Pause, relook at, revisit. We're going to be practicing with these for today and the next 3 days. So don't worry. We'll get them in your head. I know there's been a lot.